Hello everyone. Today I have a nice little trick for you to boost the performance of your ETL jobs. Now I'm going to demonstrate this in Talend Data Integration, but I've found it to be applicable to other ETL platforms as well. Now in your ETL tool, you will often find different types of CRUD options for the output components. For example, in Talend, if we have a Microsoft SQL Server output component, we can see that we have different types of actions on data. We can do insert. We can do insert single query, update, insert or update, update or insert, delete, or insert if not exist. Now some of these, like insert or update, update or insert if not exist, will check for existing records using the specified key columns. But while these options are convenient to have directly in your output components, they are quite slow when processing records. In this example, I am bringing in a small record set, and I've set my key column to data 1, which is just a unique 50-character string. I've done this to demonstrate a real-world scenario because in ETL we often work with aggregate keys. So let's take a look at what our data looks like. I have source data coming in with 150,000 records. We have a primary key ID field, we have a date field, and we have some random string fields. The destination data is basically just a copy of the source data, but it only includes the first 100,000 records. Back in Talend, you can see that I have several subjobs here, and they basically perform the same functions. In this first subjob, insert if not exist, I have the output component set to insert if not exist. So the output component will need to check if the record exists based on the key field, and if it does not exist, it will insert the record into the destination table. So let's go ahead and run this job and see what our performance looks like. Now keep in mind that this is only working with a small table of 150,000 records. That is peanuts to an RDBMS like Microsoft SQL Server. And it's also a very small number of records in many ETL jobs. I am typically working with record sets with up to 1 million or more rows. So as we can see, we're already getting an idea of our performance. It's processed just over 2,000 rows now at a throughput of about 90 rows per second. Instead of waiting around for this, I'm just going to let it finish and then come back. We see that all 150,000 rows were processed. It took 30 minutes and the throughput is about 84 rows per second. Let's go over to our destination data and verify indeed that 50,000 records were inserted. Boom. So I'm going to clear this out in preparation for the next job. 50,000 rows removed. And we're back to our original 100,000 rows. Now let's look at this next subjob titled Insert or Update. We can see that our output component is set to Insert or Update, which takes things one step further. Using the same key column, it will check if the record exists, and if it does not exist, it will insert it. But if the record does exist, it will update it. Like the previous job, this is a very common task in ETL work. So let's run this job and see what the performance is like. As you can see, we're already getting some indication of our performance. Right now it's running approximately 20 rows per second. Again, I'm going to skip ahead and jump back in when this is complete. So this time we processed all 150,000 rows at about 28 rows per second, and the final runtime of this subjob was about 88 minutes. Again, we can go back to look at our destination data, and verify that 50,000 rows were indeed inserted, and there they are. So again, I'm going to remove the inserted records, bring this back down to the original 100,000 in preparation for our next subjob. So the subjob we just ran was insert or update. This next one I have, it's called update or insert. Now in Talend, MS SQL output components have two different options that do basically the same thing. There's an insert or update and an update or insert. They do the exact same thing. I'm not going to go into the underlying differences here, nor am I going to discuss when you would use one over the other, but Talend does state that performance should be about the same. So let's run this job and see what we get. Once again, we're already getting some indication of our throughput, about 25, 26 rows per second, and climbing a little bit. Once again, I'm going to skip ahead and come back when this is complete. As you can see, all 150,000 rows were processed, but at a slightly lower throughput of 26 records per second. At 95 minutes total, that ended up taking about 7 minutes longer than the previous subjob. And once again, we'll verify that we had 100,000 records before, and it inserted 50,000 records. And I will once again clear out the new records in preparation for our final subjob. And now let's take a look at another method to get the same result with much better performance using an inner join. Now instead of letting the Microsoft SQL Server output component handle the lookup for the output records, we are going to create our own lookup using an inner join. In other ETL platforms I've used, they have specific join components. In Talend, we typically do our joins with this tmap component. This is going to look probably a lot different from many other ETL tools, but the concept we're going for here is going to be the same. We have a source record set coming in, select star from source data, and we're going to add a lookup record set from the destination database, which really just requires our aggregate key field data1 as well as the primary key of the table. And what we're essentially going to do here is create an inner join between the source data and the destination data. All the matched records will be sent to update, and all the rejected records will be sent to insert. Before I get farther into this, keep in mind that it may look a bit odd the way we do this in Talend, but other ETL platforms should have some kind of way to get the rejected records from an inner join. I will probably demonstrate this with another ETL tool after we're done here. That said, let's open up this tmap to configure our join. On the left side, this upper record set here is our source data, and this lower record set here is the lookup data from the destination database. It is bringing in all the records that already exist in the destination table. We're creating an inner join between these two record sets on our key field data1. Over on the right here is our output data. This upper record set will be all our inserts. To get the inserts, we have to set this particular output to catch the rejected records of the inner join. This lower record set will then pick up all the matched records from the inner join, which we will send out to be updated. One thing to add, you can see that these output records are keying on the ID column instead of data1. Now in this method, I change the key to the native key column in the destination table, and I do it this way because we have already manually configured this lookup using our aggregate key data1. The ID column is the indexed primary key of the destination table, and therefore is the native key column to perform an update. So we'll close our tmap, Finally, I've added a second MS SQL output component. This upper component is receiving all the inner join rejected records. And since we've manually configured our lookup using an inner join, we simply need to set this to insert. By using a simple insert, that greatly reduces the overhead on this output component. Likewise, this lower component is receiving all the matched records from the inner join, and we set its options only to update. So the suspense is probably killing you by now. So let's go ahead and run this subjob. And I'm not even going to skip ahead because I know this is going to finish rather quickly. As you can see, we can actually watch our rows processing. 100,000 rows were already sent to the update, and we're at almost 20,000 rows now going to the insert. La da da, la dee da da, la da da, la da da da, la da da. Boom, done in less than a minute. 50,000 records were inserted, 100,000 records were updated. The insert processed at 1,927 rows per second. The update processed at 3,873 rows per second. And just for completeness, let's verify we had 100,000 records before, and we now have 150,000 records. So that about wraps it up. But if you want to keep watching, I'm going to do this same method in another ETL tool. Otherwise, thanks for watching, and we'll see you next time. For those of you sticking around, I'm going to once again clear out this the updated record or the inserted records, and we're going to go back to our original 100,000 records. So for this example, I'm going to be demonstrating this method in QlikView Expressor Desktop, which I don't even think this software is in development anymore, but my company still uses it for some of its legacy ETL work. I already have it installed, I'm familiar with it, but at the end of the day it'll just give you an idea of how you can use this method in other ETL platforms. I already have my configuration set up, including source and destination database connections, the source and destination database table schemas, and some schema types that are predefined to include certain columns. So I'm just going to forego all the configuration and start building our job. First thing we'll obviously need to do is bring in our source data, connection to source database. Schema is the source data table, and the schema type is all columns. Of course, we're also going to need our destination data lookup from the destination database, destination data table, and lookup columns, which I have predefined as only including the ID column and the data1 column. Of course, we'll need to drop a join in here right away and connect the two record sets to the join. We'll configure our join keys as data1. Join type is inner. And we can go ahead and start dropping some outputs. The first output component we will connect will be for updating records, and that's going to come off the main output of the inner join, because once again these are all matched records. Destination database connection, destination data table, and the schema type will be all columns. We're going to set the mode here to update on key field ID. The next output component we're going to need will obviously be to insert the records that were rejected from the inner join. In QlikView Expressor, there are two reject ports for the join component. There's one here and one here. For inner joins, it is this first reject port that will give us our rejected inner join records. So we'll connect that to our output, which we'll set to insert records into this destination database table. schema type is insertable columns. I have this schema type set up because it does not include the ID column, which is an auto-incrementing integer. The mode is going to be normal in QlikView Expressor. These are the options: bulk load, normal, update, merge, delete. Normal is just a simple insert. So this is just about done. I'm going to go ahead and run it. Again, it's not going to take too long. We're going to watch our output window at the bottom here. And there it goes. Finished. As we can see, we have sent 100,000 records to our update component, 50,000 records to our insert component. And if I verify that in our destination data table, rerun this, and we have 150,000 records, and it took about a minute. So that about does it. I hope this helps you out a great deal. I know this greatly increases the performance of my ETL jobs, and like I said, we're working with 100,000, 150,000 records here. That's nothing compared to a lot of the ETL jobs that I am working with nowadays. So once again, thanks for watching, and see you next time.